All right, so let's start, right? Do it again. Yeah, we're trying to do right now. Well, let's check you off as possible. Okay. You know how it come last time? Go downstairs, right? Go downstairs. Yeah, look at change. All right. So let's start now. This is your summary here. Yeah, if you have to get some away. Right, three. I think I have 2 on 1. I think I already did. I can have 3. All right. So again, you do it 1, 2, 3. We try to spend most of the time, make sure we do all the module questions, right? So let's start now. This is your summary here. So we have to just something like that. Right, 3. I think I have 2 on 1. I think I already did. I can have 3. All right, so again, you do it 1, 2, 3. You try to spend most of the time, make sure we do all the module questions, right? Right. So let's take a look at module 1 there. The first thing is linear programming. Then we do assignment models. Linear programming, I wouldn't make it to the graph. We will just set up the inequalities and we'll talk about what we need to do, right? Then we have graph theory and we have linear Boolean algebra and thing, right? Supposed to be 2 days on module, but it might take as long as module 1. All right. So let us see. I sent it somewhere in the group, right? All it downstairs in room 5. And it's in the group, right? Module 1 and 2 in the group. I'll send module 3. Maybe. Right. So first thing, quickly, we need to remember in linear programming, right? We need to remember constraints and what's the objective function. What's the constraints again? What's the constraints? Or you can read this in the following. The constraints all inequalities that you end up with, right? And the objective function is the one you're trying to optimize, when you're trying to maximize out. Remember that? Right? And then we'll hopefully remember this on form 5. If you see the less than or fewer than, the right symbols to use, right? No more than is less than or equal to, at least is more than or equal to. Right? If it's less than or more than, it should be below the line. If it's more than or equal to, it should above the line. That's it, right? Right? The hard thing in these questions is being able to set up the inequalities, right? Not any drawing. But let's see if we can do one. I'll have graph paper. None? Might have 3. Might have 3. Huh? I think I have someone in the library, but let's see. So let's take a look at 2023. Let's see what we have, right? So the year we're trying to do 3 And the ones are linear, then we can do those. So in the end, we have all solutions, right? See that it? That's not, I think that's supposed to be shared 2022. Right, let's see any linear programming, right? There is the Boolean algebra, we'll do that after Boolean. Right, we have to get some inequalities here. Take a little read. If you can't see that, she'll send in the group. Take a little read and then we have to plot on this graph. Those who are online, you should have graph paper, right? We're just doing one graph and that's it for today. No more graphs. Take a read, set up the inequality. Coming back. Okay. Graph page. Is the book here? Graph. That one graph there, you see that result. Are you getting inequalities? Online, you're not a George, right? Mariano, you love? All right, good. Let us see if we could get it equals, So June wants to buy X oranges, Y peaches from the local market and sell them in her community, right? To make a profit, right? 40 cents an orange, 60 cents each per peach, right? So we know what's the profit equation. That graph before. That's the later, but yeah. We do a linear program, right? But it's late, but not so late. All right. So we can set up the optimization equation there, all right? But let's check out the inequality. Right? She has only 480, so she cannot buy more than 5 pictures. The orange weighs 100 grams, 50 grams. She cannot carry more than 0.8. Okay, so let's get the inequalities. How much we have there? Like 2, 3. Well, it's 4 already because x and y is more than 0, right? All right, if I could write here, if I can't write here, I will have to. I shot there. Right, those who online, you can take a look at the code. So they want the constraints, then they want you to go 1 centimeter to 5 on the x-axis. Right, June expects to make a profit of 20 cents. Okay, nice. Let's taking this off, right? So I want to write on the board. So let's see what we end up with. And then it will join, right? One to 5 is. I think both 1 to 5 are really about that. Right. So what are all our inequalities? Online video off. Some of them paying attention, only realize video off. Antonio, you realize video was off? Antonio, pay attention, you and Dexter. What's online there? 4 people. Nicholas, right? So let's set up the inequalities first, right? So the inequalities based on the information they give us. Right? X is oranges. Y is peaches. Right? So the first inequality is X is more than or equal to 0, Y is more than or equal to 0. First two, right? The oranges cost 40 cents, so that's 0.4 by X plus 0.6 by Y is less than or equal to the how much you have to spend? Yeah, hi. Yeah. 4.8. Okay? 4.8. Okay with that? Yeah. Hold on now. Right? And the next inequality is the orange weighs 100 grams, so that's 0.1. And what's the next one? 50 grams, so that's 0.05 Y. It's less than or equal to no more than 8 kilograms, so 0.8. So those are your 4 inequalities. I'll have those, right? Yeah, 1, 2, 3, 4. Anything else? Joan can carry no more than 80, so it's less than or equal to 0.8. This is 0.05 and this is 0.2. So you have the inequalities now on the scale 1 centimeter to 5 on both axes, right? 1 centimeter to 5. On both axes satisfy all the constraints, and then you have your profit equation after. Right, so set it up. We just join one alone. Set it up, use the scale. Use the scale and determine what you get. 1 to 5, right? Right, this has already key value, view. Let's put it in there for a minute. Right, let us get an idea how this shape look now. You see it? That's it. Don't see it every time. Hold on, unless I say it wrong. 1 to 5 or 5 to 1, maybe. 5 to 1 might make more sense. Yes, I will see. Question said use a scale of 1 centimeter to represent 5 units on both axes. What you use? 1 to 1? No, but yours come out better because look at how theirs came out. Yeah, 1 to 1 better. Say the thing, listen again. Let's put it on the side. No, wait, you gotta combine it. And that's what we did here?
Yeah. That is why it's supposed to be 1 equal to 5.
So I'll leave out 1. Oh, that was that.
That's what potential some 5.
I left out 1. Okay, sorry. That's wrong. I'm gonna go back to it. She has 480, so she cannot buy more than 5 features. Right, yeah, so correct, I left out 1. Y is less than or equal to 5. Add that in now. They will use a scale first, what to do. I will say if we end up with the same. Let's know, you do want to do one. I feel that's a mistake. 5 to 1 without. Like 5 to 1. I don't know what that means. Without 1 to 1. Right, shaded. Same thing. Same region, right? It didn't really affect too much. Same region. Right? I'm just for you sheet there. Right, so for those who are online, it might look like this. Right, and this is a common region here. Right, just do me a favor and just tell me what the vertices are. Well, I get pretty good. Well, I might be able to read that all. Of course, we have 0, 0 as 1. This one here is what? 8, 0. 8, 0. What's this one here? Both of them? And this one here. Huh? 2 in the middle. Which two in the middle? So which you'll get 2 points, Peter?
Yeah. Yeah, why?
Now it looks like this. It's a big space. Look like this. Just smaller, yes. So that goes to have a next point. This one. Yes, it's about the next one. And what was the last one? 6, 4, 6, 4, right? And then they plug it in the profit and they want which one was maximizes? Is 0. Here's 0.5. It's right, exactly. So it should be 5 for real. Right? It's not this point, using this point here. So it's 0.5. And then they want to maximize profit most likely, right? They want to find the maximum profit, so it comes out which one? This one? I'll work it out. So you're working out the maximum profit. Goes. So you're looking to see which one will give you the maximum. So 0, 0, that'll give you 0 here. You will have 0.2 by 8. So that's 1.6. Here will be 0.3 by 5. Right? So that will be 1.5 for $1.50. And here you will have 0.2 by 6 plus 0.3 by 4. So this is 1.2 plus 1.2, 2.4. So $2.40, right? Right? I find this scale was real low in exams. What are you gonna do? You gotta follow this scale, then realize after. Right now that's strange. But even if you use that bad scale, you'll be able to get these. All of them?
Yeah.
Yeah. Right, let's just do one more where we have to set up the inequalities, but we're not plotting the graph. But I think shares two. Huh? All right. So again, we're not drawing it. This is 2022. We're not drawing it. Let's just get the inequalities, right? Because drawing should be easy. So right, we get the same scale here, 1 centimeter supply. Sometimes I would do just copy the year before and about this 2 here. Right? Set up the inequalities and the optimization. See it? Ready? Again. Sometimes it do be simple to find what x and y. You have to figure it out. I can't tell you what x and y. Sometimes they don't tell you. I just figure out x and y they don't tell you. If they do tell you x is y and y is whatever. What one of the ways to figure it out? One of the tricks is looking at the optimization function and seeing what you have to optimize. Right? And by looking at that equation or that info, you just figure out x and y. Right, let's check out this one here now. So you have a small brewery produces drink B and drink B. Right? Drink B is X and drink B is Y. Right? Nice. To make drink A, 5 kilograms of corn, 4 kilograms of hop, and 35 kilograms of malt are needed, and then they give you the same input. But you only have 480 grams of corn. Right? So it means corn, you only have 480. Pay attention to SI units as well over here. Sometimes they just mix it up. 480 kilograms, and A is 5 kilograms. And B is 15 kilograms of corn. Right? Based on the info, that's corn, right? Online, I will show you that's not right, but it's 5x plus 15y is less than or equal to 8. Right? So now in terms of hops, right? You only have 4 kilograms of, 160 kilograms of hops. So it's 4 by x, and then you need 4 by y. Remember, you can divide them out after to make them look a little easier, right? And then malt is 1190. To make drink A, you need 35 grams of malt, and to make drink B, you need 20 grams of malt. Okay, so those are your 3 equations, well, 5 equations. And then state the maximization, state the, right, the last part is state the objective function. So the objective function is 130 by x plus 230 by y. Right, online? So if you look here, you will see the inequalities, right? Okay. When you plug the points and have a decimal, like the points again, if you want, you can change it. All the points are up. Yeah, you got to have it. Or sometimes when you want to plugin and says zero, so when you get provided plugin by it, that's all the that's all the benefits area you should plugin and says zero, find provide plugin is y is zero, so right? We're trying to average one thing. That's clear diagram. Right, x is zero, y is zero, the best points to plot. Right, so that's the way we set up the inequalities, right? Next thing you get out. You remember that we did one of the lessons where it wasn't that simple. The older year, the recent years is some. Before we switch to topics, right? I'm gonna see if I can find back that one and just talk with you. All right, once I have here, I give you all the inequalities. All right, so I'll tap on another look back at you. All right, next thing that we want to look at now is we do, right? Let's go back to the handout. Are you okay with this? Right? It just be a little tedious because you have a graph to draw, right? That's the only problem with it. All right, next, everybody's favorite Hungarian. Let's take a look at Hungarian. Right, so in a Hungarian, you make sure the matrix is square. So you take the info, you take it 5 by 5. Of late, they have most of them is 5 by 5 or 6 by 6. Most of them square, right? But what would happen if they're not square? Add a dummy row, right? You add a dummy row or dummy column. Right? And then you do the usual. You take your row, you subtract your row minimum, and you subtract your column minimum. Then you cover all these rows in the resulting matrix using the least number of lines. If the number of lines is equal to the size of the matrix, then you stop. If you end up with less, then you have to continue step 5. Step 5 is where we're going to create more zeros. Step 5 is where we're going to create more zeros. Yeah. Oh, sure. So yeah, just for root all zeros. Okay. Very good. Yeah, tomorrow. No, tomorrow. Yeah. But you come in the morning tomorrow. Oh, yeah. Right, sorry then. Yeah, so like for example, if you end up with a matrix, right? Like let's say you have something like this, 2, 4, 3. So you have 4 people, but you only have three jobs for them. You will have the values all here. But in order for you to use Hungarian algorithm, you have to have a 4th one. So you just create a dummy. Right? Create a dummy that wouldn't affect anything. So you can go ahead and do the process. And then after you create, additional zeros to do it. This is one technique. Different books say different things, but this is one technique, right? What you do is you find the smallest element that is not covered by the lines, right? And then you subtract this value from all the uncovered values and then add it back to the ones that cover twice. Means it has two lines on it. Okay? Right? And remember, cases where a maximization is required, you must first find the largest element in the matrix, then subtract each element from it after apply Hungarian. So take a look at the Hungarian first. If it says minimize, follow the 5 steps. If it says maximize, the first step is to take the largest, subtract it from all, and then apply Hungarian. Okay, and you'll get the correct answer. All right, so we kind of, and most people should know this, right? Let's go and do a few. Are you okay with that? Just remember, if it's maximization, what you'll do, right? You'll do one each, at least one each. Let's start here first, 2023. I think this year didn't have one of these topics. I had fun with it. Oh gosh. That's not that. Yeah, no. You'll see that? Right, minimize. 4 by 4, let's work it out. Do it there, and then I'll go on the board and do it, right? Right, those who online, just screenshot to them, just in case, but it's 2024. 3. 2023. Copy it down and just minimize it. People is in the group as well, right? That's right. Right? We do not need 3 or 4, so 2023, 2022, all those, right? Faster we go, the more we could cover in module 3 later on. Right? Use the algorithm to minimize, right? So we're doing a minimization problem here. Right? First thing first, let's take a look at row minimum. Right, I'm gonna be lazy, right? I will do it one and then do all right here. Right. So row minimum 40. So again, 0, 40. There's the first step, right? 0, 40, 110 minus 40 here too, that's 16. Row minimum here, 25. This is 75. This is 135. This is 55. Yeah. Here is 30. Everything here is 0. Here's 40. Here is 140. Here is 190. Right? And then here now, here is 70. Here is 120. Here is 170. Okay, that's row. Now let's look at column minima. Right, well, the third column staying as it is, right? Right, what's the row minima here? 155. So here's 5. Here is 35. And here is 15. Something bad wrong earlier. Right, next is what? 110. So that's 0. This is 25. This is 30. And this is 10. Then you have your 3 zeros. And then you have what? 40. So this is 0, this is 0, this is 35, and this is 30. Okay, right. Obviously, we have 4 zeros here. So we're going to draw our first line here, our second line here. Which one stops? You draw your next line here and draw your next line here. Doesn't matter, right? Now, let's see if we can figure out what the answer is, right? There's only 1 0 in this row, so I'll put it here. trying to figure out which ones you're going to choose, right? Here I have two options. Here I have three options. Here I have two options. Because these two coincide here, I'll choose this, and I will choose this here, which is this one here. Sometimes there are other options, right? Just make sure. If I choose here, no, I can't do that. If I choose here, so those two have to be chosen. If I choose here, and I can't write it, right? This one and that one. Okay, that's okay. So therefore, team S will get 20. Team R will get 70. Team Q will get 180. And team P will get 150. Okay, let's go again now. Did they have to be minimum time or minimum something? They have to anything applicable?
Yeah.
Right, so P is to here, Q is to here, R is to here, and S is to here, right? Minimum? Cost. So you're gonna add it up, right? Add up the minimum cost. Minimum cost, we add it up, how much again? 420. Nice. Anybody get that one line? Let's take a look at that was 23 to 22 from one time, then 21, then let's do only 3 or 4, and then move on. We skip it. I want to get a maximum, but less than one. Where is 21? 21 is a what? Twenty-one is a minimize again, 4 by 4. Oh, let's see what what size? All right, let's do 22, skip out 21, right? And then we'll tell you which one after. We'll skip out 21 because 21 is a 4 by 4 minimize as well. Yeah. Skip out 21, right? We'll go and do a maximization after. Is the one that we're doing, right? After we do 19, 19 is maximization. Right? Do this fast. And then 19. There you go. Hurry up now. You have 2 more to do. This on 19. Finish this one? Huh? Shovel out. I'll start this now, right?
Yeah.
All right, let's correct this one now. All right, so this is 1, 2, 3, 4. A, B, C, D. This is 90, 75, 75, 80, 35, 85, 55, 65, 125, 95, 90, 105, 45, 110, 95, 115. Right? So this will be your first matrix here. Right? We're going with minimum. So that's 0, 0, 5, 15. Right? Then if we go in here, this is 0, 50, 20, 30. And we go in here, this is 0, 5, 15, and this is 35. And we go in here, this is 0, oh, sorry, they're online. Forget all of us seeing there, sorry. And we go in here, this is 0, 45 minus this is 50, 45 minus this is 65, and this is 70. That's okay? Yeah. And then we have a 0 here, we have a 0 here, a 0 here. We do have a 0 here. So we minus in 5 from everything. That's 0, 25, 10, 65. That's okay? When you reach there now, let's check out the zeros. Obviously, we have 3 zeros here. So that's one line. We have 2 zeros anyway. Yeah, we have 2 here. And we only have 1 more. So we need 3 lines. Right? You can do it here, you can do it here. It's up to you. It don't matter. So because now we have less lines than the rank of the matrix, which is 4 by 4. We need to have 4 lines in order to stop the matrix, to stop the algorithm. So we go again. So you're looking for the smallest uncovered value, which is 20. So that's 0, 20 minus this, 20 minus this, 20 minus this, 20 minus this, 20 minus this. Which one again? Where? Here? Here? The last 0 in second line. It wasn't 20. Oh, sorry. I thought it was 20. But here was 20 alone. Oh, I thought it was 2 20s. Thanks. So only 1 0 we get. And then you're adding it to the values that here. It don't really matter. But 20 by this is 35. And 20 by this is 55. So now we have to do it over and see if we could stop. Huh? Well, it's how you interpret it. Some people interpret it as the ones that cross twice, you add the value, but it don't matter. It don't change anything. Right? It don't change anything. It's technically used to show that you don't end up with zeros. Right? So you're adding something. Right? So here I'm going back right here with 3 zeros. I'm going back here with 2 zeros. I go again. I miss a 0. Oh Lord.
So yeah, how do I mean?
How to go again? Huh? This one set more, but he has told me that. So I put a 0 here. Okay, now let me just change it. That lazy man thing and go. Right, so 5, I'll get 40 here. I'll get 0, 0, 0. I'll get 0. 55 staying here. I'll get 0 here. I'll get 0. Oh no, I'll lose a 0 here. I'll lose a 0 here, right? And then I'm minusing 0, minusing 5 from all of them. That's okay? It looks like that. So I went twice. So I have 3 zeros here. I have 2 zeros here. 2 zeros here. Right, I shouldn't have used this. Right, I shouldn't go there. I should come right here and 4 lines. So stop there, right? So I'm using this one here. Here's an example where we have more than one. Well, look at that. Here's an example where we have more than one. Hey, well, look at this. No, but here's an example where you can have more than one option. All you recognize that? No, but I have 2 zeros here.
1, 3, 2, 1, 0, 1, 2, 3, 2, 1.
So if I start here, right? I can choose, but I could also choose here. So all right, so let's choose here first, and then choose here, and then choose here, right? Or let's give you our next option. Huh? Yeah. So what about if we choose here, and then we choose here, then we choose here? Look, you have more than one option, right? Watch this here. You have one option. But it's supposed to give you the same thing, right? Let's do it in blue and see what you got. So it's 45 plus 95 plus 55 plus 80. How much is this? That's option one. Option one is how much? And then the black's supposed to give you the same thing. Check it and see. So it will be 40. Oh, I didn't write it. 45, 90, 65, 75. Right? Anyone can do it. Let's do one more. Let's do a maximization. Huh? I have in the group. I'm gonna sign about it. All in the group. Right? Try 19 now. So you'll get this one. Good. Try 19 there, right? 4 by 4. Oh yeah. Oh yeah. And questions where you have more than one option, you have to write both of them. Huh? Yes, I write both. Like not sign anything. So you can plug in 0 and you'll give it a problem. If it's 0, it's a maximization problem.
That's not you, right?
Yeah. Huh? picture.
I'm not sure what's the definition.
So how you know if you get through? Go back to it. And when you select, see if you can choose the maximum from each one. Then look out. If you end up choosing Hanif for 4, that means something went wrong. You might end up short, right?
So, yeah, and there's always room to do the bare content.
Yeah.
But that's
Right, so what do you want now? Hanif have one less option, but from looking at it, Hanif might have choose task 2. Hanif got what? 2 or 1? Huh? And we had 3. And Rashly get 2. What Rashly get? Rashly get 1. And Moses. And Jairaj.
74. Okay.
4. All right. I see. Right, task 1, 2, 3, 4. Jairaj, Hanif, Rashly, and Moses. We'll get one line. Antonio, what you got? All right. Before we do anything, right? What was the maximum value you got? All right. 87, 79, 90. What you got? So let's just try and do it without anything, right? So let's say we choose 25. I'm looking for the bigger numbers, right? 27. So I choose these 2 already. The biggest number here might be 19. And here 17. How much is this? It's 88 and you got 19. Right. So that means there's something higher. How much you got? 87. So there's a higher option, right? So remember the objective of the Hungarians to find the largest possible value, right? So if 19, that's one might be the answer. But let's see. How much you got? 70? Nah, but that's only low. Very low. Any answers online? I'll look there. So that's a little check that you can do. Right. So since we maximize it, we take in the what are we doing? Highest and minus in all from it. Right? No negative values. Huh? What's the largest value? 27. So we take. Right. So 27. Here will give me 9. Here will give me 3. Here will give me 5. Here will give me 10. Here will give me 7. Here will give me 2. This will give me 8. This will give me 27. Right? Remember, it's all of these values from the largest. You don't get negative values. Why do you see? Oh yeah, but all the values in the negative and then work it out. I don't like to work with the negative value. I never really use that technique. So if you use all the values negative and do the same thing, it work out. I know, I don't like that negative thing. Because you can end up with signs in the problem now. So you negate all and then you will come back.
I tried it.
Yeah, but then you see you might have a problem here.
That's right.
So you just leave it that. I'm sure I never use it because I didn't like the signs, right? End up with a problem. So you leave it dash and doesn't keep putting dash all the time. All right, let me see. Let me see what happens. What minus in again? 27. So that's 2, 3, 0, 5, 8, 1, 27, right? So that's 4, 30. Right? And then we could apply the row minimum. So that'll be 6, 0, 2, 7. Row minimum here, 5, 0, 6, 25. Row minimum here, nothing will change. Row minimum here. Row minimum here, 7, 3, 12. Then column minimum here, so that will minus in 2, so that'll be 4, 3, 0, 5. This will stay as it is. This will stay as it is. And then you minus 5 from each one here. So that'll be 2, 20, 0, 7. Right? Let's check out these numbers. Zeros, 1, 2 zeros covering everything. Start to go again. Right? 2 zeros covering everything. So this is the one that covered twice, and the lowest uncovered is 2. So this becomes 5. The lowest uncovered is 2, right? So this is 0, 0, 4, 18. This is 2. This is 1. This is 4. This is 2. And this is 5. Right? And then check it out again. One line going here. One line going here. Where you have to go again. Oh well. We gotta write it now. Right? Go one more time. So I'm gonna put so this will be 0, this will be 1, this will still be zeros here. This will be 0, this will be 0, this will be 3, this will be 17. This will be 0, this will be 6, 0, 0. This will be 3, 0, 1, 4. Right, let's check it out again now. We have 3 zeros here. 2 here, 2 here, 1 here. Right, that's what we got. Let's see what will happen now, right? 1, 0 here. We can't use here, so we come here. Can't use here and here. We have options. Right? Let's check it and see. We have options now. So we could use here. Right? Or we could use here. That's 26, 27, 20, 22. No, that's just options. If I use black. Or here. Oh, okay. So this is option 1, right? Option 1 is 26 plus 27 plus 20 plus 17. What is this? 90? 90? How about option 2? Option 2 giving us what? Option 2 is the same, bottom 2, no. Option 2 will be 26, 22, 20, 20. So 26, 22, 20, 20. Hello? Are you okay with that?
What about the right? Like,
Use negative numbers, and if I use that method, it work.
yeah, that's it. Yeah. Basically, I'm minimizing, but it's enhancing each one. So you take 1 minus 4,
So that's what I'm again saying. You're using maximum when you run the column.
Okay.
You're using maximum when you run column, and then do it like normal after that.
Okay. So you make let's get
By eliminating negative values. I saw a negative value technique once. I didn't like it. In some cases. Once you end up with this, yeah. So if it works, go ahead and use it. So when you use your negative technique, right? Oh, if you don't mistake, it should still work, right? It should still end up with just 90 as the max. What you got for your max? That's here. Huh? 92. But I want to break. Maybe you physics or again. Huh? So I'll finish it on about what I'm going to finish. Half 1, 3 or 4. All right, but let's do only Boolean and critical tomorrow. Let's do summary. Let's do graph theory and some Boolean. Any questions on this? Any questions on this? But make sure you're good with the technique, right? The reason I do it like this is that in like management and business, what we do in here by minusing off and creating this matrix, what we do in here is we minimizing the loss. So when you minimize your loss, you end up maximizing your profits, right? That's why I use this technique. It is what they do in MOB and things, right? But in maths, I guess if you put all negative, it's the same concept, right? All right, let's take a look at graph theory. Do graph theory tomorrow with critical. I wonder if we can do some. Okay, I think I should not go there. Well, the other thing was problem. Well, we can do it. Let me run through some Boolean. We just go the ones that we didn't do tomorrow. Right, so the Boolean, you all should know your gates, right? You have your AND gate, your OR gate, your XOR, your NAND gate, no, and your XNOR. Right, remember, let's remember your gates, so remember your summaries, right? Like for example, what was the summary for NOR gates? 1 always gives you a what? Actually, summary for NAND gates. And 0 always gives you a 1. Right? Or 2 ones will give you a 0, you're not good. Right? So once you know your truth tables, then we need to be able to go back to your little pure maths, right? Where you could take the gate and find the logical equivalent connector. So for example, AND gate is that symbol there. What is called again? What is beside AND? What is call it in maths? Conjunction. And then O is what? this juncture. Then you have your AND gate is in negation. Right? The AND gate is negation. Right? You have to know your biconditional tables. Remember, the main one to learn in conditional is a false implies true will always give you. Sorry, a true implies false will always give you false. For biconditional, false implies biconditional, false is true. True biconditional is also true. Right, next. We need to remember converse, inverse, contrapositive. Converse, switch it around. Inverse, negate it. Contrapositive, negate it and switch it around. Okay? Done? Okay. Right? A tautology, everything is true. A contradiction, everything is false. All right? And then, sadly, you have all these rules to learn here. When they say Boolean algebra, you have to know all these rules. Right? But the good thing is you can kind of memorize them, right? True or any, you can kind of work it out, not memorize it. You kind of work it out. True or anything is anything. False or anything is anything. Right? So some of these rules here, we can kind of work it out. Next thing we have to know is a switching circuit. An OR gate is always written as a parallel switching circuit. An AND gate is written as a series switching circuit. Okay, that's it. Series and parallel both. So those are things you have to know about Boolean algebra. Huh? Don't know anything? But I just went through it. Go over any of them? Switching circuit. All right. What's the switching circuit here? The switching circuit, whenever you have the OR, you draw a parallel circuit. Whenever you have an AND, you draw the series circuit. So for example, if you have something like this here. Right, we'll just do one and then I'll give you a break for physics. Next class, we'll do all the rest of this and critical part. Right, so switching circuits. Let's say we have the negation of P or Q. Right? And R. Let's say I have something like that, right? And I want to draw this switching circuit here. Or it's parallel and it's series. Right? So in order for you to draw this, you have your parallel circuit first. You have your parallel circuit first, the negation of P, Q. And this is in series with R. That's it. That's a switching circuit for that. Right? And you have to be able to go vice versa. Okay? You have to be able to go the other way around as well. Let's try 2024 and that's it, right? Huh? 2023. I don't never know when I might see this. Let's say, yeah. So like, you have it, send it. I have 2024 and that's it. You know what I mean? 2020. If you could find 2024, we're doing it. 2023. Huh? right? So in words, what's the first one? It is not 38 degrees today, and it is Tuesday. So we got that? Good, let's close that one. It is not 38 degrees today, implies it is not true. It is Tuesday. Next one. It is 38 degrees today, if and only if it is Tuesday. So you have that? Well, that's the last one, by conditional one. So we have that battery. That's here. Yeah, that is battery. Right? It is 38 degrees today, if and only if it is Tuesday. I don't know, Antonio. You want to use because. Yeah, that could probably work because. Yeah, but because it's not fully conditional. Yes, no, use if and only if. Right, Antonio? Use if and only if instead. Next part. Right, what is the converse of if I live in England, then I live in London? The converse is, let's switch it around. If I live in London, then I live in England. Okay? Inverse is, I do not, if I do not live in London, then I do not live in England. Oh, wait, no. That's a contrapositive. The inverse is where we just negate, switch it around. Converse is switch, right? Negate, just negate. So if I do not live in England, then I do not live in London, right? And then the contrapositive is if I do not live in London, then I do not live in England. Okay. You already should table. How many variables you have there? Two variables alone, right? So you have four options. What is the tautology? I'll get you the tautology part. Dexter, Antonio. Right? If you just take a little glance on the board, you will see it, right? Right, if you check at the camera, you'll see the tautology, right? Just click on the camera and you'll see it. And last part. Huh? Yeah. Last part. Two. I will do all the and I'll give you a break, right? I will do all the and we'll continue with the next. All true. Right, derive the Boolean algebra expression for each one. Right, you can have it. Tell me now. Huh? P and Q, or P and R, and Z as well. That's not. This is Y and Z as well. Q and Q or R. Nice. Huh? Oh, sorry, Q. But again, last part, this is the last part of your stuff. But again, this. Given that the switching circuit Y is logically equivalent to the switching circuit of X, and the cost of using one switch per hour is 6, determine the savings for a year. What? Well, did they give you anything else before?
So 6.
So they wanted to use Z. Oh, no. So they want the cost of using Z rather than Y. So if it's here, what you did here? Huh? Oh, it just would go in number switches. But N is said Y, that's not. So given that the switching circuit Y is equivalent to Z, and the cost of using one switch is 6. Right? So if you go back up here, you have 4 switches, and here you have 3 switches. Okay. Right? The cost of using one is 6. Determine the savings for a year of using Z rather than Y. Right, so no, but look here, it's just a number of switches. You have 1, 2, 3, 4 switches here, and you have 3 switches here. So it's 4 by every switch, right? By 365, right? That's it's an hour, right? It's by an hour. And here is 3 by 6 by 365 by 20. And then it it's 4 switches. What is circuit? PQ, PQ, P and R. Huh? Yeah, or you can just multiply by 1. You're saying that's saying literally counting the number of switches in Y, right? You have 4 switches, P, Q, P, and R. And then it's 4 switches by 24 hours, $6 for one by 365 days. And do the same thing here. In real way, not real way question. All right. How much you got? 500, huh? Right, that is savings. All right, so that's the savings there. All right, we still have more to do in it, so we'll take a look at the rest of that, and we'll look at some more questions in Boolean and physical part next day, right? All right, so I wanted to give you a little break before.